Welcome. What we're going to do today is we're going to look at the atomic structure with respect to protons, neutrons, and electrons. We can denote protons with a P+, plus written as a superscript after the letter P. Neutrons is N0, the 0 written as a superscript after the N, and electrons E- with the negative written as a superscript after the E. With those three subatomic particles, where are they located? The protons and neutrons are located inside the nucleus. They're also known as nucleons, whereas electrons are located outside the nucleus in the electron cloud. Okay. Now what we're going to do is we're going to compare and contrast those nucleons with the electrons outside. The nucleons inside that nucleus, that's where all of the mass of the atom is going to exist. Whereas in the electron cloud, almost none of the mass of the atom is in the electrons. As a chemist, we basically ignore the mass of electrons because they're between 1 and 2,000 times smaller than a proton or a neutron with respect to mass. Conversely, when we look at volume, the volume of the nucleus is next to nothing. In Ernest Rutherford's gold foil experiment, that's what he discovered. He discovered that, hey, there's this nucleus. It's really, really small, and it's really, really dense. When we think about density, density is mass divided by volume. Looking at this atomic structure where nearly all of an atom's mass is in the nucleus, but nearly none of the atom's volume, what that does in that equation, density equals mass over volume, that makes the numerator very large and the denominator very small, makes the density extremely large when those conditions exist. On the other hand, the electron cloud is mostly the atom's volume, and it's going to be mostly empty space. And finally, let's compare. Let's compare the mass of protons versus neutrons. The mass of protons and neutrons is essentially the same. They're essentially balanced. There's no difference there. On the other hand, when we compare electrons to protons and neutrons, the mass of an electron is much less than the mass of a proton or a neutron. Now what we're going to do is we're going to look at appropriate notation when writing element symbols. Our example today is going to be sodium, which has a symbol Na, has the atomic number of 11, mass of 22.99 AMU. Those AMU atomic mass units. What that represents is essentially the mass when you have 1 mole of a substance. So 22.99 grams when you have 6.02 times 10 to the 23rd atoms of sodium. Then our mass number is, in this case, going to be 23. It's always going to be a whole number for us. And right now, we're just simply going to round the atomic mass to get the mass number. It's not actually what you are supposed to do, but for the time being, it's going to suffice. We'll learn the correct way to identify a mass number in the future. Finally, the charge. The charge in this case is going to be 0, but charges will range from -4 to +4. Now let's take a closer look at the atomic number. The atomic number is also the number of protons in a given atom or given element. When the atom is neutral, okay, that is, it has no charge, the number of protons will equal the number of electrons. However, if it is negative, you can see that the number of protons is going to be less than the number of electrons. If it's positive, the protons will exceed the number of electrons. Kind of makes sense. Protons are positively charged, electrons are negatively charged. The way I write appropriate notation, because this slide is going to be all about appropriate notation, we have our symbol Na, and then as a subscript before the element symbol, we'll write 11, representing the atomic number of that element, sodium. Next, we're going to take a look at mass. The mass number is 23. The mass number is 23, and we can calculate mass number using the equation mass number equals protons plus neutrons. In this case, it is sodium. So the mass number is 23. We have 11 protons. we need to calculate the number of neutrons. 11 plus 12 equals 23. So the number of neutrons in this case is 12. And how do I denote the mass number in my notation? I use a superscript here of 23 to represent the mass number. And finally, let's look at charge. So in this case, the charge is going to be 0. To calculate charge, it'll be charge equals the number of protons minus the number of electrons. So since the charge is 0 and we have 11 protons, 11 minus 11 would be 0. In the notation end of this, on the notation end of the spectrum, we have sodium, our symbol, 11 as our atomic number written as a subscript in front of the symbol, 23 our mass number written as a superscript before the symbol, and our charge will always be written as a superscript after the symbol. In this case it would be 0, but we should omit it when there is no charge. So technically, charge shouldn't be written in this case.